All right. So, video. This video is coming after a very long time. I have been busy understanding some topics, and I'm making slow progress, to be honest. But anyway, uh, again, I wanted this to be a structured video, but it is not. But I thought let's just do it because there's not much information. Like there might be. In at least in my search results, YouTube does not show too many or too many videos regarding this. So it is a bit for a newbie. It is a bit of a task to completely understand what is this. And then these are confused with people tend to call this thing limit supremum and this thing limit infimum. However, this is limit superior, this is limit inferior, this is supremum, this is infimum. All these four are different, and going by the color, you can tell that these two are somehow related and these two are related. But otherwise, limit superior has nothing to do with, I mean, it can, there can be cases where it has everything to do with Supremum, but generally it is an entirely different thing, entirely different concept. Yeah, whatever. So let's dive into it. Okay, first thing, yeah, let's begin from there. These are defined on sets, and these are defined on sequences. This is the first notable difference. Okay, I'll start with supremum and infimum. Supremum is also called the least upper bound, and infimum is called the greatest lower bound of a set, right? So if, say, you have a set S which has A, B, C, D, E in increasing order, so okay, that would not make sense. This is a set, but this supremum infimum, okay, this is defined on sets of real numbers. A set which is a subset of reals. That's where it is defined, not even on complex. Reason being, the complex field is not ordered. Real is ordered. Okay. And I said complex field. Let's not give any footage to that. Field is a different concept. I'm still studying it, to be honest, and I'll make videos on it when I understand it properly. Anyway, coming back, this is a set, but we are not taking this set. So what we'll do is we'll take a set of numbers, real numbers. Let's say minus 1, 7, 21, oh, 47. This is random numbers I'm picking. 10 to the power 99. Okay, this is a very random set and it is bounded. Okay, let's take a few more sets. S2 to 10 to the power 99. Yeah, and let's first play with just these two sets, S1 and S2. S1 has 5 elements, S2 has uncountable elements. Okay, this set is infinite, S2. However, what is the supremum of these sets? Well, supremum of S1 is 10 to the power 99. Why? Because for all s belonging to S1, s is either less than or equal to 10 to the power 99. That means there is no element in the set that is greater than or equal to 10 to the power 99. There is some mistake there. Oh, yeah, yeah, yeah. I said it wrong. I'm sorry. There's no s in the set which is less than or equal to 10. It is equal. Okay. I'm sorry. Yeah. Apologies. All elements of the set are either less than or equal to this quantity we are taking, 10 to the power 99. All elements are either less than or equal to this. Nothing is greater than this. So this is a bound on the set and a bound from the upper side. So it is the upper bound, right? And 10 to the power 99. Yeah, it is the upper bound. Okay. Now, is it the only upper bound? Well, no, obviously. After 10 to the power 99, we can have 10 to the power 99 plus alpha, where alpha is any real number, positive. Okay. Not even zero. Yeah. Any positive real number, as small as you please. If you add to that, it will be more than 10 to the power 99, and it will also be a bound on this set. No elements of the set would exceed this no matter what alpha you take. So if we were to represent it on a number line and here as 10 to the power 99, so any number beyond this, all real numbers beyond this actually, they are a bound for this set, right? Similarly, okay, and let's stick to this first. Yeah. Now let's come to S2. Again, the same thing. 10 to the power 99. There is no element in this set S2 which is more than 10 to the power 99. It is either less than or equal to 10 to the power 99. So, supremum of S2 is also 10 to the power 99. And I said something wrong. See, 10 to the power 99 is not included in the set. So in this case, all s belonging to S2, all s will be strictly less than 10 to the power 99. They will never get to 10 to the power 99, right? because 10 to the power 99 is not in the set. Hope you already know this. So, but still, 10 to the power 99 is the bound because there is no number in this. Yeah, there is no real number. You cannot identify the real number which is just to the left of 10 to the power 99 on the number line. Like, you cannot point out a number here that, okay, this I'm giving you alpha, we have already taken, like this beta, this is the number which is just smaller than 10 to the power 99. There is no such number. Any number you give or any number you can think of, there is there are infinite number of rationals and irrationals between those two, right? Yeah, I think I'm over explaining this particular part, so I'll skip it. So 10 to the power 99, both these sets have their supremum as 10 to the power 99. 10 to the power 99 is itself contained in this set S1. However, 10 to the power 99 is the upper bound of S2, but it is not contained in S2, right? Also, any number greater than 10 to the power 99 will also be a bound on this set because no element of the set can exceed these numbers. Your set finishes here. Nothing can go beyond this on the number line. So every number on this side of 10 to the power 99 is an upper bound, right? Both the sets, same upper bound. In one case, upper bound is contained in the set. In other case, it is not contained in the set, even though the other set is infinite. And this first set is finite, only 5 elements, right? And now since there are uncountable upper bounds, but the smallest of all is 10 to the power 99. That is why it is called the least upper bound. So least upper bound is the supremum of the set. Similarly, infimum, same idea, same concept, right? I don't think it needs an explanation. So I'll erase all of this and we'll move to limit superior and inferior. And honestly, that was what I really wanted to explain. But yeah, people, even when I was learning these terms for the first time, even I was confused that what's the difference between supremum and limit supremum. Then I realized that, okay, it is not even limit supremum, right? And I forgot how to erase it. Control X. Yeah, right. I forgot how to erase it. Just give me a moment. I haven't used this in a while. And okay, sorry, bear with me. If it takes too long, I'll edit it. Control A, Control X. What? Okay, this is not working. To be honest, I'm shocked that I forgot. Control X, Control A, Control X. Okay, it is not working. Wow. And you can just go there. All right. So limit superior now. Yeah. Limit superior and limit inferior. Now, this is a concept on sequences, right? So let's take a sequence, I guess. Okay, first let's understand what kind of sequence is available. Also, this is how I tend to look at a sequence. On x-axis, I plot, let me, okay, yeah. On x-axis, I tend to plot natural numbers, and on y-axis, we plot the terms of the sequence. We'll do that in a moment. Also, uh, I said that I plot it like this. It's not something I invented. Okay, uh, all all this is just knowledge gained from different sources. I'm not inventing or creating anything new. Okay, this is just simplification and an amalgamation of all the knowledge from few different sources that I get it from. Yeah. So a sequence. Let's take a sequence. Let's take a sequence of natural numbers, right? N belongs to natural numbers. I'm not going into the details of what a sequence is because I'm assuming you already know this. And again, if the viewer feels the need to understand a topic which they have tried and are still not able to figure it out, just let me know in the comments and I will make a video on it. Okay? Yeah. So, a sequence of natural numbers. Yeah. So, let's take A1 as the sequence n, where n belongs to naturals, right? An. So A1 is 1, A2 is 2, A3 is 3. So similarly, if I defined a sequence like this, An is 1 plus 1 by n, right? Where n belongs to naturals. So A1 would be 1 plus 1 over 1, that is 2. A2 in this case would be 1 plus 1 over 2. A3 would be 1 plus 1 over 3, and so on, right? You get the gist of it. So this representation is how I tend to look at sequences when I need to visualize them, right? So I'll be taking the second sequence. Okay, let's take the second sequence and let's get rid of this. Let's get rid of this. Okay, it's like collecting all the dust and wiping it under the mat. Feels like that. Anyway, so yeah, this is the sequence we are taking, an, right? Now let's plot it. So let's mark a1. A1 is 2. Let's mark it here because this is a decreasing sequence. No, it is increasing, but is it? No, it is decreasing, right? See, the first term is 2, the first term is 1 plus 1, then 1 plus half, then 1 plus 1 by 3. So what we are constantly adding to 1 at each subsequent step, it is decreasing. So the sequence is decreasing. That's why I'll mark my A1 here. A1 is 2. Okay. So let's write 2 here and A1 here. Now A2 is, so if this is 2, then this is 1, and I can get rid of this, right? So yeah, A2 is 3 by 2, that is 1.5. A3 is 1 plus 1 by 3, 1 plus 1 by 3 will be here. Okay, let me draw this. Uh, this is our line 1. This line represents the value 1. So 1 plus 1 by 3. A4 is 1 plus 1 by 4. 1 plus 1 by 5. 1 plus 1 by 6. 1 by 7. 1 plus 1 by 8. 1 plus 1 by 9. So it will keep on decreasing like this, right? It will keep on decreasing like this. It will never be 1. 1 plus 1 by n. As n will approach infinity, 1 by n will approach 0. So this sequence will approach 1 plus 1 by n. This will approach 1, right? Because 1 by n is approaching 0. So the terms of this sequence will become arbitrarily close to 1. Okay? But it will never be 1, right? Okay, and yeah, since we are at it, let's take one more sequence, 1 minus 1 by n, right? So a1 in this case will be 1 minus 1, that is 0. a2 will be 1 minus 1 by 2. So I'm marking it here. A1 is 0, a2 is half, a3 is 1 minus 1 by 3. So what we are subtracting from 1, that quantity is continuously decreasing. At each subsequent step, what we are subtracting from 1 is continuously decreasing. So this will also approach 1, but this will approach 1 from below, and this will be an increasing sequence, as you can observe. And this 1 plus 1 by n, okay, I should see 1 plus 1 by n. This is a decreasing sequence approaching 1, and 1 minus 1 by n is an increasing sequence approaching 1. All right. Now these sequences are called monotonic, strictly monotonic rather. Okay. Our first sequence 1 plus 1 by n is strictly decreasing, and 1 minus 1 by n is strictly increasing, right? Now comes this definition, limit superior, limit inferior. Okay, I think I was reading the book by Professor Bartle. Yeah, and I think there it was, I can't remember the book. Okay, yeah, but anyway, see, limit superior, limit inferior has to do with the limit point of a sequence. Now, in both these sequences, 1, we can clearly observe that 1 is the limit point. And let's stick to one sequence first. Let's stick to this a dash. Okay, no, that does not. Oh yeah, let's stick to just this 1 plus 1 by n, right? So this sequence, 1 is the limit point of the sequence, right? And it is the only limit point. So limit superior means, I should not have taken this. Okay, let's just uh, let's just take a break from this and consider random sequences. Okay, or why random? Let's take this sequence. an is minus 1 to the power n, right? So the first term for n equal to 1, a1 will be negative 1, a2 will be 1, a3 will again be negative 1, a4 will be 1, and like this. So the terms of this sequence, I'm not drawing all the index now and scale, just I'm just drawing the points, okay? And see, a1 is negative 1. Let's say this is negative 1 and this is 1. a2 is 1, a3, a4, no, a5, okay, 1, 2, 3, 4, 5, 6, 7. And this much should be enough. 1, 2, 3, 4, 5, 6, 7. Right? Now, see, a1 is negative 1, a3 will be negative 1. Whenever n is odd, the value of the sequence will be negative. a5 will be negative 1, a7 will be negative 1. On the other hand, a2 will be 1, a4 will be 1, a6 will be 1, and so on. As we approach infinity, we can observe that the even terms, they will give the value 1, and the odd terms will give us the value negative 1. So in this case, the terms of the sequence will accumulate around 1 and negative 1. So we will get two limit points in this case, right? Negative 1 and 1, two limit points. And this is where the concept of limit superior and limit inferior comes in. So for this sequence, limit superior is 1. That means the largest limit point of the sequence, right? And limit inferior is negative 1, the smallest limit point of this sequence, right? I hope this makes sense, and I hope the video is not too long yet, because I still need to tell some stuff. Okay, so let's quickly draw another thing. Right now, I'm plotting the kind of sequences we may encounter. Okay, and you can make any sequence. It's not like even if you're not able to explicitly define the terms of a sequence, that should not be an issue. Okay, so just randomly, we will I'll show you the kind of sequences we might get. Okay, so okay, first, a sequence can start like this, and it can keep on increasing and increasing till infinity. In that case, okay, what is the value this sequence can take? Let's say this is 1, and then it keeps on increasing. Let's say this is this sequence. See, so there is no limit point here, right? So limit inferior does not exist, right? There is no limit point. Limit superior is approaching infinity. Okay, so in this case, what limit superior is infinity, we call, right? There is no limit point. but the terms are accumulating at infinity. That is why we can say that limit superior is infinity, right? However, if you look at the range of the sequence and if you form a set, that set would be 1 to infinity. Now this set itself has a supremum, sorry, has an infimum. This set has an infimum, which is 1. Limit inferior does not exist. There is no limit point. Infimum is of the range of the sequence. So you have to identify what we're talking about, if it is limit inferior or if it is infimum, right? So don't get confused in this. And in this case, supremum does not exist. There's no upper bound on this set. So supremum won't exist, right? Yeah, now coming back to, oh no, wait, I'm sorry. Let me, yeah. So see this sequence we got, which was bounded below and it was increasing. Okay. Now what other kind of sequence we can get? Other kind of sequence can be a decreasing sequence, right? So arbitrarily, let's say an is negative n. So it will start from -1 and it will decrease till negative infinity. Okay, that is a vague thing to say, but yeah, it will decrease. And then what other kind of sequences we can have? Yeah, -1 to the power n times n. You can yourself, okay, evaluate this. First one, all terms will be negative. -1. Okay, let me change the color. So this sequence would be like this. Next point here, next here, then here, then here, then here, then here, then here, then here. From one side it will continuously increase and from the other side it will continuously decrease. So it will oscillate infinitely, right? Between infinity and negative infinity. No limit point. Okay. Then what kind of sequence we can have? See, these are unbounded sequences. Then this brown sequence, it is bounded below, unbounded above. This red sequence, it is bounded above, unbounded below. And then this green sequence, it is unbounded, neither bounded above nor bounded below, right? We won't call the brown sequence unbounded. We will call it bounded below. Red sequence we will call bounded above. And this green sequence we will call unbounded, right? And when does a sequence converge? Well, a sequence converges when there is when the limit superior and limit inferior, they both are equal. That means there is just one limit point. That means all the terms of the sequence are accumulating around one value, right? proper definition, you know that we get an n naught such that for all m greater than n naught, a m minus whatever this limit point is. In this case, it is 1. Otherwise, we call it L. This is less than epsilon for all epsilon greater than 0. Okay? And this is pretty simple to explain. And there are videos on this. So I will not be explaining this. You can check out those videos on YouTube, right? But yeah, this is the concept. When limit superior and limit inferior is the same, implying that the largest limit point and the smallest limit point, they are the same. Like in this case, this was the smallest limit point, this was the largest limit point. So this sequence cannot converge when limit inferior is different and limit superior is different, right? A sequence converges when limit inferior is same as limit superior, right? And one last thing, that very popular definition of, not definition, the method to find limit superior, that you create a set A1, A2, A3, and you take the supremum, and let's say without loss of generality it is A1, then you leave that, let's call it B1, B2, then you leave first term, okay, let's take AK somewhere, AK, this was the largest, say, then we leave the first term, A2, A3, A4, remember AK will still come, AN, again we take the largest value, say that is AK, this is the largest value, it is still in the set. What is happening is, okay, first BK, we have left all these terms out till here, till AK, and now we have this AK till AK plus 1, so on till AN. We are still taking the supremum, right? And this we keep on doing till BN, supremum of AN. Now, okay, AN, okay, this, and then we take the infimum of these, infimum of BN. Now, this can get confusing, but if you look carefully, what is happening? See, your sequence, let's say, either it can be like this, say it is converging, right? I'm taking various examples. If it is like this, then your AK lies somewhere here. This is AK, right? Infinitely, okay? So, no matter whatever terms you are leaving, this, the value of B1, this will always be this largest point, largest limit point, AK. So no matter how far you go, see, this is arbitrary, this is approaching infinity. This K is not, might be finite. Oh no, it is not finite, okay? Okay, don't restrict yourself with a finite value in this. So as you keep moving, you will always keep getting this largest value. Let's say it is here, arbitrarily close to the limit point, okay? So no matter, like, people get confused with infimum, that it is the smallest value. Okay, no, it's the smallest value, when you're taking the largest. So if your sequence is like this largest value, you will always be getting the largest value. So even the infimum will be this same thing. Okay. So this will be the limit superior. Okay. Now consider another sequence. Okay. Just a moment. Uh, Consider another sequence. Yeah. Okay. Again, same thing, which is decreasing. Okay. Let's say sequence starts from here and it keeps on decreasing. And this is not necessarily zero. I'm taking zero somewhere here, right? This is our limit point. Or maybe zero is above. Okay, no. See, okay, this is some random limit point, C, right? So your AK, now see, you're taking the supremum, right? So in this case, this first, A1 will come here. For B1, we will get A1 against when, and then when we leave A2, sorry, when we will leave A1 in the next step, we will get A2 because A2 will be the largest. Then A3 will be the largest, and so on. AK, okay, AK will be the largest at this step, right? At this step, AK will be the largest. Then you will leave AK. This now this is continuously decreasing. So you will get an AR which will be close to the C, arbitrarily close to C, like extremely close to C. Okay, so you'll keep getting smaller and smaller value. You will never get C, but when you repeat this process infinitely, you will be getting arbitrarily close to C while you are decreasing, while the values are decreasing. So what will keep on repeating here? Even if nothing repeats, this, can you observe, this will keep on decreasing, and then you will have to take the infimum of this set. To get to the limit inferior, you will have to take the infimum, the smallest value. And you can observe then that in this case also, you'll get the limit point as the smallest value, right? I'm not sure if I'm able to convey this properly, but I hope I should be. Okay. Yeah. Now let's again, oh my god, I wonder how long this video will be. But anyway, now another step quickly. See, what if it is oscillating like this? Okay, and it is not even convergent. Okay, so observe carefully. You are to pick the largest value. So no matter where you go, this will be the largest value, this will be the largest value. No matter how many terms you take, no matter how many terms you take, this largest value won't change, and this I'm taking as the largest limit point. Okay, so no matter what values are contained in this set, when you take the supremum, you will always get this value, the largest limit point, C, right? So it does not matter if you take the infimum of this set, you will always have this value, right? So even in that case, even if you are taking the infimum, you will be getting the largest limit point of that sequence. This is what I'm trying to explain. That don't get confused with this word infimum. Just put the possible scenarios of how a sequence can be, and you will realize that okay, this process just means that we are collecting the limit point, largest limit point. No matter what case it is, monotonic, increasing, decreasing, oscillating, in all these cases, This infimum will still lead us to the largest limit point, is what I'm trying to explain, right? And you can repeat the same process with the process of finding limit inferior. It is just the inverse process. We take infimum here and then take the supremum of that. That will always give you the smallest limit point of the sequence, and that will be the limit inferior. Okay, make up all these cases and you will figure out, right? And if you still feel that this needs more explanation, write in the comments, or I will make another video about it, right? Yeah, that's it.